Asset retirement obligation is a legal requirement and obligation that companies in extractive industry and in nuclear reactors have to uh, recognize liabilities in the future for the future removal and dismantle of their operating infrastructure. Usually you hear about it with oil and gas, and because oil and gas industry is the, I think, most common that interact with everyday's life of everybody. So with oil and gas companies, they have to remove the oil platforms, oil plants, treatment plants, wells. They have to decommission them, remove them, and restore the sites to their original state. So when the company starts a project or build an asset, as soon as they build the asset, they have to recognize the liability that in the future, at the end of the life of that asset, when they, how much it's gonna cost them to remove it, they have to recognize it as a liability, and they have to add the offset as an asset to the cost of the asset. They add it to it. And then they accrete annually that liability, because we will see in the example, we bring it to the present value and then we accrete it until we reach that amount of the future. So the best way to understand this is to go over an example. And let's assume an oil and gas company is going to build a platform, offshore platform, and this company estimates the cost of that platform to be $5 million and will stay for 10 years. Okay, so the company, as soon as they build, they plan this, they have to go out to contractors and say, okay, in 10 years, how much would this cost me to remove it? So contractors would come with quotes. Let's say they say in 10 years, for removal, labor would be 700,000, and then equipment used would be 300,000, and let's say 100,000 contingency. That's for changing prices and inflation, etc. Not inflation per se, but other factors. And contingency 100,000. So that's total of 1,100,000 in 10 years. In 10 years. So now, that's why I said not inflation, because now we have to go, the company would go and say, okay, what's the rate of inflation in their region where they are going to install this platform? And let's say they find out by the central bank and other entities that it's 2%. So now we have to get a factor. So this is inflation. We get a factor for the inflation, so 1 plus 0.02, which is inflation, to the point of to the power of 10, and that would give 1.219. So we take the 1,100,000 times 1.219, and that equals to 134,900. So this is the cost adjusted for inflation. Now the company would have to consider what we call market risk. Market risk is the changes in regulations and delays in the market and some stuff like that. So let's say that the market risk premium is 5%. So this 5%, to account for it, so we say 1 plus 0.05 times the inflation adjusted cost, and that would equal to 1,407,945. So now we have inflation and risk adjusted cost. Now we are good with the cost and risk adjustment for the market. Then we have to bring this, the company then goes and says, okay, now we have the estimation of the from the contractors, and we have the inflation adjustment, and they have the risk. So that now they go and say, okay, we have 3 scenarios. So they make 3 scenarios. First one is, they say best case scenario, or scenario A, and that they say in 10 years they think it's gonna cost 1 million actually to remove, and the probability for that is 30%. And then we have a neutral one, which is our number, that's the middle one, at 1,479,445, and they say there is a 60% chance this will happen. And then C, the pessimistic, and they would say it's 1,600,000, and that's the remainder of this 30, so 10%. And then we get the result of each, 1,300,000, and that's 844,767, and then we have 160 for the last one. The total of this is 1,304,767, and this is our ARO in 10 years. What we need to do now to bring it to the present value, and to bring it to the present value, we need to discount it, and for discounting we need a discount rate. And how do we get discount rate? Is first we take the same duration, so we go risk-free bond, which is the government bond, for 10 years. We get the rate of that, and the rate, let's assume, is 3%, because it's always low, because it's risk-free, usually the government. and now we then take the company credit risk of the company, and that's we get it from credit ranking by Moody's or Standard and Poor's, I think. Moody's. Okay, let's say it's 3%. So we have a total of 6%. Now we can discount the number we have. So we say present value of the 1,304,767 divided by 1 plus 0.06 to the power of 10. And here we get 726,084. And this is the number that we record the liability for the asset retirement obligation. So now we have the number to record the liability. So first we say now we have what's our journal entry. First is asset, so platform debit to increase it or to create it, so 5 million is the cost plus 726,084, that's the liability cost or cost of removal. So we add it to the cost of the asset, and then we have to create the liability, and we have to credit our other asset, cash, which paid for this. So cash 5 million, and then we have ARO, and it is 726,084. Now at the end of the first year, and at the end of every year until this asset is retired, we have to recognize accretion expense. What is accretion expense? Accretion expense is the expense that's gonna add to this liability until it reaches the number which we discounted, which is 1,304,767. So first, the carrying value of the asset, and then we have accretion, and then we have ending balance. So we start with 726,084, which is this present value, and then the accretion, it's the interest rate times the carrying value, and this is the accretion plus the carrying value. So this we multiply by 0.06, we get 43565, and this becomes the ending balance 769,649, and this goes here to become our carrying value 769,649, and then next year we multiply this by 0.6 by this, so we get 46179, and it changes every year, so we get to that number, and the carrying amount goes up to 815828, and it goes on until it reaches about that number. It's 1,304,000. Here it will reach 1,300,304, and that's good enough. So at the end of first year, we recognize the accretion expense. So we say accretion expense, and that's 43565 debit, and then we increase our liability, so ARO liability goes up by 43565 by crediting it. Okay, so now let's assume year 4. Now let's assume in year 4, okay, assume year 4, prices went up, labor prices went up to the point where it increased the total cost of removal to 1.5 million. So the company has, in this case, has to re-measure its liability. So now, because we know the cost has become 1.5, so we get the present value of the 1.515, and then 1.06 to the power. At the end, this is year 4, end year 4, so we have what left of the period? 6 years. So to the point of 6, and we get 1057426. That's the new liability. So this 1057426 minus the carrying value at end of year 4 by our old estimate, which is 916665, and we get 140761. Now we have to increase our liability by this amount and our asset value. So we say asset, platform, 14761, and then we say ARO credit to increase 14761. So now we have, now let's assume we go back to our number, the same number. That this is just in case it changes. This is the way you deal with it. Now, if it didn't change and we went to our numbers back, so at the end, we paid 1,400,000 paid actual, and then our liability amounted to 133,304 estimate. So 13 minus the liability, we have to, okay, So 1 4 minus 300 304 equals 99,696. This is a loss. Okay, so it's a loss, so we debit loss on ARO settlement. Why is it loss? Because what we paid is more than estimate. If the estimate is more than what we paid, we get a gain, and that goes into the credit side. So loss on ARO settlement by 99,696, and then we bring the ARO to get rid of it because it's a liability, so we debit it to remove it, and this is ARO, and the opposite side is a credit for what we paid, and that's cash, and that's it. Thank you. I hope this helps.